Okay, good morning to all of you. In this class, we are going to discuss velocity and acceleration in spherical polar coordinate system. In short, I have been written SPCS. In our last class, we have been discussed velocity and acceleration in cylindrical coordinate system in detail. Okay, so let's we have to start today class. So before we have to start our discussion, again I am going to suggest to you that you have to go through the video where I have been discussed the importance of the orthogonal curvilinear coordinate system. In this video description also I will give the link of this video. You have to watch this video, orthogonal importance of orthogonal curvilinear coordinate system. Then you have to watch this video and it will be easy for you to understand. Okay, so let's start today's class. In general, velocity and acceleration of a particle is represented as v equal to rate of change of position vector, and acceleration is nothing but double derivative with respect to time of position vector, that is your d square r by dt square, or rate of change of velocity that we know, where r is the position vector. So to evaluate velocity and acceleration in SPCS, first we have to consider the position vector in Cartesian coordinate system as I cap x, j cap y, k cap z. I am going to show you that in case of spherical polar coordinate system, here you can see, this is the, you can check your note, this is the diagram of your spherical polar coordinate system. Any point P in spherical polar coordinate system can be represented by Cartesian coordinate system, and we know that Cartesian coordinate system, spherical, both are coupled with each other. And this spherical polar coordinate system, we found z equal to r cos theta and x equal to r sin theta cos phi, and y we found r sin theta sin phi. So these informations or these results also we are going to be used in this today's video. Okay, so to find velocity and acceleration in spherical polar coordinate system, first r, that means this one, position vector, has to expressed in terms of spherical polar coordinate system, because this is represented in your Cartesian coordinate system. First I have to transform this position vector to spherical polar coordinate system, then we are going to be find out the velocity and acceleration. So same thing, it has been written, r has to be expressed in terms of spherical polar coordinate system, hence x, y, z and corresponding unit vectors I cap, j cap, k cap has to expressed in terms of spherical polar coordinate system, that is your SPCS. Previously, as I told, previously we know in SPCS, x is your r cos theta cos phi, y r sin theta r sin phi, z r cos theta cos phi, and corresponding unit vectors are belongs to x. This is your e r cap, e theta cap, e phi cap. This is your radial component, this is your theta component, and this is your this is belongs to azimuthal change, e phi cap. That means may you remember, I am going to show you that whenever we have been discussed the spherical polar coordinate system, at that time I told corresponding u vector is transformed to r v theta w phi, e1 cap unit vector for u curve is transformed to er cap for r curve, radial curve. Here v, when transformed to theta, corresponding unit vector will be e theta cap, phi means e phi cap. That already we have been discussed at that time. So these results we are going to use now in this content. Okay, so here x value, y value, z value and corresponding er cap, e theta cap, e phi cap we are going to be used in equation number 1, right? So the equation number 1 will be, here you can see I cap x, instead of x we can write r sin theta cos phi, r sin theta cos phi, plus j cap y is nothing but r sin theta sin phi, r sin theta sin phi, k cap is there, z means r cos theta, k cap r cos theta. Let this is your equation number 1, sorry, equation number 2. So from this equation number 2 you can see that here x, y, z component are transformed to polar coordinate system, but I cap, j cap, k cap are not. That means this equation number 2 is not fully converted to spherical polar coordinate system, right? So what we have to do, here you can see. So the unit vectors are e r cap, e theta cap, e phi cap, that we know in case of spherical polar coordinate system. So here I cap, j cap, k cap, how we are going to be transformed in this form, here I have been discussed. Okay, here you can see that if we are going to consider er cap, that is nothing but er by del r and its magnitude, that we know previously. Okay, so e1 cap is nothing but E1 cap is nothing but del r by del u by del r by del u modulus corresponding to u curve, that we already discussed from our initial video. You can watch that or you can check your note. Likewise, E2 cap is nothing but del r by del v by del r by del v mod for v curve. So as u curve is transformed to r, then its corresponding e r cap will be written as what? Del r by, instead of u we have to write del r divided by del r by del u, del r by del u, instead of u we have to write del r modulus. Same thing it has been written. So instead of v we have been written theta, and theta instead of w we have to write phi correspond to e phi cap. Okay, so e r cap will be del r vector by del r by modulus of these things. So here this is the r vector, position vector. So we have to consider del r by del r. Here you can see, if we are going to consider this term, then the differentiation with respect to r will be sin theta into cos phi, because here r is only there. So differentiation with r, that means only we can get sin theta into cos phi. Next, second term will be sin theta cos phi, differentiation with respect to r, sin theta cos, sin theta sin phi, sin theta sin phi. Third term will be only cos theta. Then modulus of this one, modulus of this one means square of this one, square of this one, and square of this one. Here the modulus of this value will be 1. How it is? The modulus of this one, numerator, will be how much? Here you can say sin theta cos phi square plus sin theta into sin phi square plus cos square theta root over, right? So here you can see this will be sin square theta cos square phi sin square theta sin square phi. Take common sin square theta. Okay, so we can get cos square phi plus sin square phi plus cos square theta whole root over. So this value is 1, right? So we can get sin square theta plus cos square theta root over is nothing but 1. Okay, so here the modulus of this one is 1, right? Now we are going to go for the del r by del theta by its modulus. That means each and every term in the equation number 2 differentiated with respect to theta. So here this term is going to differentiated with theta, means only sin theta will be differentiated. R cos phi are constant, so r cos theta cos phi. So r cos theta cos phi, when it will be differentiated with theta, right? So again, when this term is going to differentiated with theta, we can get j cap r cos theta sin phi. J cap r cos theta sin phi. So this term differentiated with respect to theta, that means we can get cos theta means minus sin theta. So minus r sin theta, minus r sin theta, k cap is there, k cap. Now we are going to consider its modulus. That means here you can see square of this one plus square of this one plus square of this one. So r square we can get, right? So here r square will be common for all three terms. Okay, so can be taken outside, and inside we can get cos square theta cos square phi, cos square theta cos square phi, cos square theta sin square phi, cos square theta sin square phi, and sin square theta whole root over. So here if we are going to take common cos square theta from this term and this term, we can get cos square phi plus sin square phi, which is equal to 1. Again cos square theta plus sin square theta, again it will be 1. So we can get r square root over, that means r. So if we can take common from all the terms r in the numerator, this r will be got cancelled, and we are going to get I cap cos theta cos phi plus j cap cos theta sin phi minus k cap sin theta. Okay, so here we found E theta cap is nothing but this much. Okay, so this is your radial unit vector, and this is your, you can say, this is your tangential or vertical or theta component unit vector, and phi component unit vector is this one, that del r by del phi and its corresponding modulus. So here you can see in equation number 2 we are going to be, we can get in this term phi cos phi sin phi in this term, and here in this term there is no phi. So derivative with respect to phi for this component will be 0. Okay, so derivative with respect to phi for this term will be, here cos phi means sin phi. So this will be I cap r sin theta, cos phi derivative will be minus sin phi. So here r sin theta into cos phi, r sin theta, derivative of sin phi cos phi, j cap is there, as I told, differentiation with respect to phi for this term will be 0 because it not contains any phi. Okay, so k cap 0, and its corresponding modulus will be how much? Square of this one, that means r square sin square theta sin square phi plus r square sin square theta cos square phi, and it's a root over. Okay, so here you can see that if I am going to take sin square theta r square sin square theta common from these two terms, then we can found sin square phi cos square phi is equal to 1. So here r square sin square theta will be there, root over means we can get r sin theta. So here r denominator we can get r sin theta, numerator here you can see r sin theta one term and r sin theta one term taken common means r sin theta cancelled with denominator r sin theta. We can get minus I cap sin phi, here minus I cap sin phi, here j cap cos phi, So this is your E phi cap. Okay, now consider E r cap, E theta cap, E phi cap. For equation number 2, the equation number 2 will be, you can see here, equation number 2 is this one, I cap r sin theta cos phi, j cap r sin theta sin phi, k cap r cos theta. Here you can see E r cap is nothing but I cap sin theta cos phi, j cap sin theta sin phi, k cap cos theta. So if I am going to take r common from these three terms, then what I can get? Here you can see r taken outside. If I if r taken outside, then it will be sin theta cos phi plus j cap sin theta sin phi k r taken outside, so it will be sin theta cos phi, sin theta sin phi and cos theta, which is nothing but your er cap. Okay, so after taking r common from these three terms, we can get this one, sin theta cos phi I cap, j cap sin theta sin phi, k cap cos theta. So here this r position vector can be written as r, which is taken outside, r into er cap, right? Hence equation number 2, this one is transformed to this one, r vector, that means position vector will be equal to r er cap. So here in equation number 2, this equation number 2 not fully represents the spherical polar coordinate system, but here you can see this equation number 3 fully represents the position vector in spherical polar coordinate system. Here you can see there is no I cap, j cap, k cap and all. These two terms are belongs to spherical polar coordinate system. So equation number 3 represents purely position vector in spherical polar coordinate system. Now we are going to evaluate velocity in spherical polar coordinate system by using position vector in spherical polar coordinate system, which is your equation number 3. Got it? Okay, so velocity, we know that rate of change of position vector, rate of change of position vector is nothing but r er cap. So consider the product formula. So d by dt of r into er cap plus r into d by dt of er cap. Okay, so as we know that d by dt of something is written as r dot. Okay, so here d by dt of r means we can write r dot er cap plus r d by dt of er cap, written as usual. Let this is your equation number 4. Now here er cap, you can see that er cap is the function of theta and phi, which is changes always with respect to time. So we have to find out the d by dt of er cap will be how much. So we have, that means we have to simplify. We have to simplify what will the value of d by dt of er cap, because er cap is a function of both theta and phi. So for that we have to calculate this one, that d by dt of er cap, we know that this one we have to consider this and substituted over this one. Now we are going to consider d by dt of each term, this one and this one. So d by dt of this one, here you can see I cap d by dt of sin theta cos theta into d by dt of theta, that means theta dot into cos phi, then minus I cap sin theta cos phi derivative with respect to t, that means sin phi, sorry, minus sin phi. So here minus came, minus I cap sin theta sin phi, phi dot. Okay, cos phi differentiation with respect to t is nothing but minus sin phi into d phi by dt. Sin phi d phi by dt can be written as phi dot. Okay, next this one. Next we have to consider the differentiation of I cap. So sin theta cos phi d by dt of I cap. Now we have to consider second one, the j cap differentiation with respect to t of sin theta cos theta into theta dot sin phi, then j cap sin theta sin phi differentiation with respect to t, that means cos phi into phi dot. plus sin theta sin phi d by dt of j cap, right? Okay, next we have to consider this one. So k cap cos theta derivative with respect to t minus sin theta into d by dt of theta means theta dot, then cos theta d by dt of k cap. Okay, here you can see rate of change of unit vector, rate of change of unit vector along y axis. This is your z axis. Here I cap is a constant, j cap k cap are constant vectors, so this term will be 0. So this term will be cancelled out, right? So finally we can get d by dt of er cap will be equal to, here you can see that these three terms, here you can see this one and this one contains theta dot, here theta dot, theta dot, theta dot. So theta dot taken common, we can get I cap cos theta cos phi, here j cap cos theta sin phi, okay, and here minus k cap sin theta, minus k cap sin theta, and here these two terms, in these two terms phi dot is common, so phi dot taken outside, here j cap sin theta cos phi, j cap sin theta cos phi minus I cap sin theta sin phi, I cap sin theta sin phi, right? So here you can see this one I cap cos theta cos phi, j cap cos theta sin phi minus k cap sin theta is nothing but your e theta cap. Here we found this one. So instead of this much, we can write e theta cap. Similarly, from this term, what we can get? See, phi dot is there, sin theta taken outside, sin theta. So rest of the terms are j cap cos phi minus I cap sin phi. So j cap cos phi minus I cap sin phi is nothing but e phi cap, j cap cos phi minus I cap sin phi, j cap cos phi minus I cap sin phi, this much is nothing but e phi cap. Here we found already. Now we have to substitute these things, e phi cap. So phi dot sin theta e phi cap. So here we found d by dt of er cap is nothing but this much. So now equation number 4 will be r dot er cap r into d by dt of er cap. So d by dt of er cap is nothing but this one multiplied with r. So r theta dot e theta cap, r theta dot e theta cap plus r phi dot sin theta e phi cap, r sin theta phi dot e phi cap. Here phi dot sin theta is there, I written sin theta phi dot, no problem. So r sin theta phi dot e phi cap. This is the required expression of velocity in spherical polar coordinate system. Here we have to stop our discussion today. In our next class, we are going to discuss about acceleration in spherical polar coordinate system. Okay, so thank you so much for watching this video. Thank you.